Hello everyone, welcome back to ANR Academy. This is Nepal sir. Today we are going to discuss how to find area of the parallelogram when four sides are given. Let us see the proof. Suppose that a parallelogram which is formed by the equation of lines. First line, that is ax plus by plus p equal to 0. Its opposite line, opposite side ax plus by plus q equal to 0. Next, remaining two sides. Suppose they are cx plus dy plus r equal to 0 and cx plus dy plus s equal to 0. These are four sides of a parallelogram. Assume that this is the figure. These two are parallel and remaining third and fourth also parallel. We know that parallel lines have same slope. Slope depending upon coefficient of x and coefficient of b, so that they must be same. Only the difference in constant. Ax plus by, ax plus by. Up to here, the equations having the same quantities, that is same coefficients, only the difference in constant. These two are parallel. Up to here, x terms and y terms, they are same, only the difference in constant. To find the area of the parallelogram, here you have to use this formula. Area equal to in the numerator p minus q multiplied by r minus s. In the denominator part, determinant of a, b, c, d. By using this formula, we can find the area of the parallelogram. Let us see the proof of this. To prove this result, we have to discuss two sub-concepts. They are angle between two lines and distance between parallel lines. With the help of these two topics, we can easily find area of the parallelogram found by these four lines. Let us discuss first what is distance between parallel lines and what is angle between given lines. See, suppose that if the two lines are parallel lines, ax plus by plus c1 equal to 0, ax plus by plus c2 equal to 0. These two are parallel lines. Then to find distance between these two parallel lines, you have to use this formula. Distance equal to modulus c1 minus c2 whole divided by root over a square plus b square. This formula we have to apply to find the distance between given parallel lines. Next, second one, how to find angle between intersecting lines. You know the formula to find angle between the lines. Suppose the lines are a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Then you have to apply either tan theta or cos theta. Tan theta formula a1 b2 minus a2 b1 cross multiplication, a1 b2 minus a2 b1 divided by a1 a2 plus b1 b2. Here I am going to write the formula a1 b2 minus a2 b1 divided by a1 a2 plus b1 b2. You may also use cosine angle formula, and cosine angle formula, that is a1 a2 plus b1 b2 divided by root over a1 square plus b1 square multiplied by root over a2 square plus b2 square. So these are the formulae related to angle between two intersecting lines. Generally, acute angle and obtuse angle, both the angles formed, but only we can define acute angle is angle between the lines. Due to that reason, here modulus is applied. Both tan theta and cos theta, acute angle, since theta is acute, the result must be positive. Due to that reason, here modulus is applied. Yes. Now, with the help of these two results, you can prove this one. See, how can you prove that? Yes. These are first two equations. They represents opposite sides of a parallelogram. First one, ax plus by plus p equal to 0, and this is ax plus by plus q equal to 0. Next to two parallel lines, they are cx plus dy plus r equal to 0, cx plus dy plus s equal to 0. Here we need to find area of parallelogram. Yes, the area of parallelogram I am going to divide into two equal parts just by this diagonal. If you draw a diagonal within the parallelogram, then the diagonal divides the entire portion into two equal parts, so that just by calculating the area of this triangle, multiplying with 2, then you will get area of the parallelogram, that is double the area of triangle. Here I am going to mention the result as twice area of triangle. Assume that here the parallelogram whose vertices are, here it is capital A, this one capital B, and it is capital C, and it is capital D. You may write 2 times of area of triangle ABD, or you may write 2 times area of triangle BCD. I am going to write 2 times area of triangle ABD is area of parallelogram. Now my aim is to find the area of triangle ABD. You know the area of the triangle? A simple formula half into base into height. Yes, I am going to write half into base into height. 2 gets cancelled and we get base into height, and the result must be positive, so that I am going to put modulus sign. Here observe the triangle ABD. AB is the base, so that I am going to write here in place of BC, that is length of AB. Next, height of the triangle. Here height of the triangle, that is if you drop a perpendicular from point D to opposite side AB, this is known as height. And this height, if you observe the figure, let us see, this height is clearly distance between these two parallel lines. I am going to extend the line AX plus BY plus P equal to 0. This is AX plus BY plus P equal to 0, and this one AX plus BY plus Q equal to 0. And clearly this one is height is distance between these two parallel lines. And we know the distance between parallel lines. In the numerator you have to write difference of constants divided by root over sum of squares of coefficients of x and coefficient of y. The same here I am going to apply. Here the two lines are AX plus BY plus P equal to 0 and AX plus BY plus Q equal to 0. In the numerator you have to write the difference of constants, that is P minus Q. And in the denominator part you have to write root over A square plus B square. Yes, it is P minus Q divided by root over A square plus B square whole modulus. Next, my aim is to find the length of AB next. So to find the length of AB, here I am going to use remaining parallel lines. Remaining two parallel lines I am going to use. Just extend AD and BC. I am going to extend the line. Yes. Line is AD and this is BC. These two are parallel. Yes. Now to find the length of AB, I am going to drop a perpendicular from the vertex A to the opposite side. This is the perpendicular I am going to drop from vertex A to its opposite side. This is the perpendicular, and there is a triangle, and from this triangle see here, this is some distance small d. This is the distance between these two parallel lines, and here the requirement is length of AB. If suppose theta is angle made by two adjacent sides of a parallelogram, since these two are parallel lines, and here it is the angle theta, because of these two are alternate angles. These two are parallel and this is transversal, so that if theta is angle between two adjacent sides of a parallelogram, then automatically in this triangle here the angle also theta due to alternate angles. Now from this I am going to write sine angle. You know that sine theta, which is defined by opposite divided by hypotenuse. Here d opposite divided by hypotenuse is length AB. But the requirement is AB, so that AB written as d divided by sine theta. Yes, now I am going to replace AB with this result, that is d divided by sine theta, and here it is p minus q divided by root over a square plus b square whole modulus. But d is distance between these two parallel lines. I am going to replace that in the next step. Yes, on continuation, this is equal to, first I am going to write 1 by sine theta, next small d, after that p minus q divided by root over a square plus b square whole modulus. Next, you know that d is the distance between parallel lines, so that using the formula mod c1 minus c2 divided by root over a square plus b square, here I can write difference of constants r minus s, so that distance r minus s divided by root over, here the coefficients c and d, so that we get c square plus d square, and the last term p minus q divided by root over a square plus b square, which is as it is. Next, 1 by sine theta we have. See here, if I write tan theta equal to sine theta divided by cos theta, then I can write 1 by sine theta as 1 by tan theta into cos theta. I can write sine theta as tan theta into cos theta. Yes, here in the denominator part, sine theta I am going to write product of tangent angle and cosine angle. We know that if theta is angle between two intersecting lines, you know the result of tan theta and cos theta. Using these two results, here I am going to get tan theta value. Remember here, tan theta can easily remember in this way, a1 b2 minus a2 b1 divided by a1 a2 plus b1 b2. The same rule here I am going to apply for these two adjacent sides, c into b minus a into d, or a into d minus b into c, whatever it is. Due to modulus sign, you may write ad minus bc or bc minus ad. So here in the next step, I am going to write first tangent angle result, 1 divided by tangent result here, ad minus bc divided by a into c plus b into d, a into c plus b into d. Next, you need to write cosine angle. Cosine angle formula, a1 a2 plus b1 b2, tan theta denominator equal to cos theta numerator. Yes, tan theta denominator, here it is ac plus bd. Okay, the same here, cos theta numerator, ac plus bd divided by, see in the denominator part what you have, root over sum of squares of coefficients of x and y. Here sum of squares of coefficients of x and y, one is root over a square plus b square and the other root over c square plus d square. So 1 by tan theta into cos theta result over. Next, remaining r minus s divided by root over c square plus d square, p minus q divided by root over a square plus b square it is. Now these two gets cancelled. Also root over c square plus d square, root over c square plus d square, root over a square plus b square, root over a square plus b square gets cancelled. And finally we get in the numerator product of p minus q and r minus s. In the denominator part we get AD minus BC. I can write AD minus BC as determinant of 2 cross 2 matrix ABCD, and in the numerator P minus Q into R minus S as it is. So this is the formula to find area of parallelogram when equation of sides are given. I hope the students, those who are watching my videos, they must like, share and comment. Thank you so much.